Good day, students. Welcome to mathematics class. Welcome to mathematics class. Today, we'll be considering the topic set theory. Set theory. You must have heard about this before. This is one of the topics in mathematics. Set is actually used to classify various objects in a collection. Let's say, for example, you have a set of school materials. You have set of school materials. Let's say you have books, you have chair, you have eraser, you have pencil, you have chairs, you have tables. So you can classify those as what? Writing materials. For books, for pencil, they are writing materials. Why the chair, table are what? Are furnitures. You understand? You can classify them as furnitures, though they are actually categorized to be used in a school setting. Let's say in a classroom, for example. So classroom is actually the universal set, while the categories, the subset, are the furnitures and what? And the writing materials. You understand? So those, the pencils, the eraser, the chairs, are the elements embedded or that exist in that, inside that collection, inside that category. You understand? So set is basically the classifying of various sets in a collection, and from there you're able to get to know the interaction, the relationship between those materials. So we have different types of set. We have different types of set. We have different types of set. We have universal set. We have subset. We have empty set. So let's talk about the universal set. It is represented with moon. That sign you are seeing is a Greek sign, moon. You understand? Or the other Greek letter is a Greek letter. It's a Greek letter. So that's the letter in which a universal set, when you say universal set that's being represented with those two letters, then you know that they are what? They are universal set, because it contains other smaller sets in that classification or in that category. Because it contains other smaller sets. It's a universal set, a set that contains all other sets. So it's a big set. For example, that moon is inside that the curly bracket 1 2 3 4 5 6 7. A ní àwọn letters yẹn. Àwọn letters yẹn ni ọ̀kan èjì ẹ̀ta ẹ̀rin àrún ẹ̀fà èje ẹ̀jọ ló wà, ló jẹ́ a bigger set, ló jẹ́ ètò tó kájú gbogbo ẹ̀ ní wọ́n fi ń pè ní universal set. So we have other set A tó wà nínú curly bracket tó jẹ́ 1 3 5 7, and also B tí àwọn element tó wà nínú ẹ̀ jẹ́ 2 4 6 8. Those are the subset. And you will see that of all the subsets, you will find all elements present in that subset are all in the universal set. So universal set encapsulate or get all other sets in the subset into his own domain. You understand? So that's basically what a universal set means. So we have subset is just, for example, that subset is what we're having here. This is a subset. This is also a subset. So just as A in the above explanation is what is a subset of moon, that is A subset moon. Do you understand now? So because all the elements of set A are in what? Are in more. So that's just it. So it's a subset. It's a subset of a bigger universal set, because gbogbo element tó wà nù A òun náà ló wà nù kíni o, ló wà nù the universal set more. Although some textbooks actually represent some other the universal set with some other value, but that's the universal one. So we have empty set. It's a set that has no element in it at all. It is represented by phi or open empty curly bracket, and it is also what it is called a null or void set. It is called a null or void set because it contains no element. Element that has no element, set that has no element in it are called null or void set. So let's see the relationship between those sets. We have union. Union is actually the relationship, the mutual relationship between two sets. You understand? Between two subsets now. Understand that between two subsets, between two sets that are being given. So, but the combination is just like, for example, if A is having 1, 3, 5, 7, and 9 as elements, and B is having 1, 9, 25, 49, and 81. Then the union of sets A and B consists of elements belonging to both sets. Understand now? Either to A or B. Either to A or B. Either to A or B. Either to A or B or both. So it is represented by A union B. So if you have A union B, you see that all elements that you can find in subset A and B, or set A and B, can be found in A union B, which is 1, 3, 5, 7, 9, 25, 49, 81. And most times they are being written in ascending order, or a regulated order. So let's go to another relationship that you can find between sets. You can find intersection. Intersection is simply where those two elements meet. What is common to both sets? What is common to both sets? Where those two elements or three elements meet actually. So element of any set that is common to two or more sets. So that's basically what we call intersection of sets. So for example, if A is having 1, 4, 9, 16, 25 as element, and B is also having 1, 2, 3, 4, 5, 6, 7 as elements, then A intersection B, which is represented with this, A intersection B is actually what? What can you find here and you can find there? Kí ni nǹkan tó lè rí bí? Tó lè rí bí? A lè rí 1B, àbí? A lè rí 1B. Ṣá lè rí 2B, a lè rí 2, kò common. Ṣá rí 4B, a rí 4B, a rí 4B. So tá bá wò, a rí pé 1 and 4 are the common elements inside the two of those sets. That's the two sets. So that means the intersection is what? 1 and 4. So that's why it is written like that. So nǹkan tó pa wọ́n papọ̀ ó ní 1 and 4 là ń pè ní intersection, bí tí wọ́n ti jọ papọ̀, nǹkan tí ó wà nínú A tá lè rí nínú B, and union la pè ní pé okay o, ìkórajọpọ̀ gbogbo element àwọn nǹkan tá lè rí nínú kíni, tá lè rí nínú A tá sì lè rí nínú B. So tó bá ti kó wọn papọ̀ just like this, then you have actually gotten what is called the union of set. So let's now move to difference between those sets. Sometimes we have ìyàtọ̀ máa ń wà, ìyapa máa ń wà láàrin àwọn set yẹn. Wọ́n dẹ̀ máa ń bi wá léèrè pé nínú ìdánwò pé ká mú ìyàtọ̀ àbí ìyapa tó wà láàrin wọn wá. So that's why we have the difference between two sets. For example, if set A is having 1, 3, and 5 as element, and B is having 4, 5, 6 as element, then A minus B will be what? A minus B will be what? 1 and 3. Ìtumọ̀ ẹ̀ ni pé wàá yọ àwọn ẹ́límẹ̀ǹtì tó wà nínú B tó lè rí nínú kíni o, tó lè rí nínú A ni wàá yọ kúrò nínú, wàá fi get answer rẹ̀. Those elements that you can find in A but you cannot find those elements that you can find in B but you cannot find in A, you remove it from what? From the set, from the element in set A. That will give you the answer. Do you understand now? So wàá rí pé element wo ló wà nínú A? A ní 1 3 5 àbí element wo ló wà nínú B? A ní 4 5 6. So tá bá fẹ́ yọ B kúrò nínú A lálákọ̀ọ́kọ́ tá kọ A minus B. Be very careful of èwo ló wà níwájú nínú méjèèjì. A ló wà níwájú, so A ló dúró, B la fẹ́ yọ kúrò nínú kíní. So èwo ló wà nínú A, èwo ló wà nínú B tí ò sí nínú A? A rí pé 4 ò sí nínú A àbí? A rí pé 5 ó wà nínú A. A rí pé 6 kò sí nínú A. So 5 nìkan ni wọ́n ti jọ ṣe kíni o, wọ́n ti jọ common. Ìyẹn láwàá yọ kúrò nínú kíni o. A ṣáà lè yọ nǹkan tí ò sí nínú nǹkan, a lè yọ kúrò nínú nǹkan. So eléyìí tó wà lára A yẹn láwàá yọ kúrò ńbẹ̀. So èyí tó bá ṣẹ́kù, the remains is what to do what? The remnant is what to write as A minus B. And let's consider B minus A. B is written first. So that means a wo element tó wà nínú A tí ò sí nínú B, a wá yọ kúrò. You understand? A wá yọ kúrò. Kí ni element yẹn? A ní 4 5 6 nínú B. Àwọn element wo ló wà nínú A tó common sí B? Just 5 ni. So nígbà tó jẹ́ pé 5 ni, a yọ 5 yẹn kúrò nínú element tó wà nínú B. Ètò tó wà nínú ìyókù tó ṣẹ́kù nínú B lákọsílẹ̀. That's why we have 4 and 6. Know the difference so that you don't mix it up. So, and also notice that also B minus A is equal to B minus bracket B intersection A, or A minus B is equal to A minus open bracket A intersection B. So take note of that. For you to confirm if you get the result, if you get the answer here correctly, then just try and do this, then you are good to go. So this joint set is when we have two sets that have what? That have no elements in common. So when you have two sets but they have no elements in common, there is nothing that is common to both of them. We have they are disjoint. That is, the elements in A are not in B, and those that are in B are not in A. Then the two sets A and B are said to be disjoint sets. So, and is equal to what? A intersection B equals to what? 0. So kò sí nǹkan kan tó ṣe kíni o, to when you have A intersection B to be what? Null, void, to be 0, then you have your what? You have them to be a disjoint set. You can see 1 4 and 5, and this is 2 and 7. Kò sí nǹkan tó wà nínú B tó wà nínú A, kò sí nǹkan tó wà nínú A tó wà nínú B. So they are disjoint sets. So we have complement of a set. All elements in a universal set. All elements in the universal sets are what? That are not in a given set is called what? It's called the complement of that set. Don't forget that we said something about universal set, which is a set that comprises of all elements that you can find in other subsets. You understand now? Now, complement of that set is now that if you cannot find, if you have a universal set and you cannot, and they are not in that set that is given, then you write it out as what? At the complement of that set. You understand? For example, the universal set has 1 2 4 6 8 10, while the subset has just 2 and 6, right? That's just 2 and 6. The complement of Q will be what? Those elements that remains in the universal set that you cannot find in what? That you cannot find in that subset. That's it. We can find 2 and 6 in the universal set, but you are not going to write out those sets that you can find in that universal set, but the one you cannot find in that subset. Do you understand? You cannot find that, so you are writing 1 and what? 1, 4, 8 and 10, because those are the elements you cannot find in subset Q, and those elements are called complement of Q. They are complement of Q. So let's follow this example. Let's just take you through this example. If universal set is having this element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have subset P which is having 2, 4, 6, 8, and we also have subset Q which is having 2, 3, 5. They ask us to find P intersection Q, and they ask us to also find P union Q, and they ask us to find complement of Q. They ask us to find complement of P. I think with the explanation done before, you should be able to do these questions. So let's go in solving it. P intersection Q. Níbo ni P àti Q ti pàdé? Kí ni nǹkan tó so wọ́n papọ̀? Kí ni element tó wà nínú P tó wà nínú Q? Let's check. We have 2, we have 4, 6, 8. What of this Q? We have 2, 3, 5. You can see that only 2 is common to both. Only 2 is common to both. 2 ní element tó common sí P àti Q. That's why we have P intersection Q to be what? Ibi náà ti pàdé is 2. So let's go to question 2. P union Q. P union Q should give us the what? The combination of the two elements. The combination of the elements you can find in P and Q. So let's start from P. We can find what? 2. Abi, we can find 2, we can find 3, we can find 4, we can find 5. And when you see elements that are common to both, you don't write it twice, you only write it once. Like for example, now we have 2 in, you have 4 in, we have 2 in P, and we also have 2 in Q. It is written once. You understand? So, and all other elements now follow it. Tó bá ti rí number, tó bá ti rí element tó ṣe kí n tó jọra wọn nínú element kan nínú set kan, ò ní kọ́lẹ̀ méjì, ẹ̀kan náà ló kọ́ torí pé ó ti sora papọ̀. 6 and 8. So written those things out actually gives you what? The union of P and Q. P union Q. So the complement of Q, àwọn ni kí ni universal set wọ́n fún wa? Universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wọ́n fún wa. Now kí làwọn element wà nínú Q? Àwọn element wà nínú Q ni kí ni? 2, 3, 4, 5. Àbí 2, 3, 4, 2, 3, 5 rárá 2, 3, 5. So àwọn èyí tí ò sí nínú tó ṣẹ́kù, tí ò sí nínú àwọn èyí tó ṣẹ́kù nígbà tá a ti yọ ti Q kúrò ńbẹ̀, àwọn yẹn ni à ń pè ní complement. So àwọn wo ló ṣẹ́kù nígbà tá a bá ti yọ 2, 3, 5 ńbẹ̀? I mean ó ṣẹ́kù 1, ó ṣẹ́kù 4, ó ṣẹ́kù 6, ó ṣẹ́kù 7, 8, 9, 10. So those are the what? The complement of set Q. And also the complement of what? Of P is what? Àwọn kan ló wà nínú P. I need 2, 4, 6, 8. Àbí I need 2, 4, 6, 8. So tá a bá yọ 2, 4, 6, 8 kúrò nínú the universal set given to us, we are left with what? 1, 3, àbí 5, 7, 9 and 10. So those elements are called the what? The complement of set P. So with this, we've come to the end of today's class. In the next section, we'll be talking about those representing sets with using Venn diagram. Venn diagram, I think, is one of the crucial aspects of set theory. All right, keep reading, keep studying.